Bismillahirrahmanirrahim. In today's lecture, we are going to learn about surds. What are surds? Surds are irrational. Any irrational number is called a surd. Okay. So surds are basically irrational numbers. Okay. The most basic definition of surds. So if you have an irrational number or an expression involving irrational number, then that irrational number is called a surd, and the expression will also be called a surd because that expression will give you an irrational answer. Now, we obtain surds when we have surds when we come across unresolved nth roots. What are unresolved nth roots? For example, if I want you to find the square root of 32, okay, then the basic method that we have learned is that we find the prime factors of 32. Okay, prime factorization, as you did in the early classes, in junior classes we did this. After doing this, we are going to obtain 2 into 2 into 2 into 2. Now if I want to take the square root of 32, what am I going to do is I am going to pick 1, 2 and pull it out of the square root sign. Whenever I get two number of 2's, I am going to pull 1, 2 outside the radical sign. So I am going to get 2 into 2. From here we are going to get 1, 2 outside, and from here we are going to pull the other 2. But over here with this 2 we don't have any other 2, or this pair is not complete. So 2 will remain in the square root. So it means that we can't resolve this square root. Okay, so whenever we have such numbers or such whenever we have such question in which we can't resolve the root, okay, the nth root, it can be square root, it can be cube root, it can be fourth root. Whenever something remains under the radical sign, okay, then we say that this number will give us a surd because this number is always an irrational number. Okay, so the square root of prime numbers are always irrational because they remain in the square under the radical sign. We can't pull that number outside the radical sign, therefore it remains under the radical sign, and this always gives us the irrational number. So the square root of prime numbers are always irrational. This was one example. Let us take another example. Suppose you want to find the cube root of 81. Again, for cube root, what do? We first do the prime factorization, and after doing the prime factorization, which 81 will be 3 into 3 into 3 into 3. After doing the prime factorization, if you want to find the cube root, what do? You pull 1 3 out of every 3 number of 3's. Okay, so if you have 3 number of 3's, 1 2 3, then you pull 1 3 outside the radical sign. Now we can get 1 3 outside this radical sign, but this 3 will remain under the radical sign. Okay, we can't find its cube root. Okay, we can't get its cube root in the whole numbers, and this is also an unresolved cube root. Okay, so all unresolved nth roots gives us the irrational number. For example, cube root, square root, or fourth root. If you are finding the fourth root of some number and you can't pull all the 4 outside the radical sign, then if something remains under the radical sign, then this number always gives us an irrational number. Okay, these are the examples of irrational numbers. In your course we have just square roots, this type of surds, okay, which are obtained by taking the square roots of the prime numbers. So we will be dealing with these types of irrational numbers, and any expression involving this type of surds will also be called surds. Okay, any expression or an irrational number, or any expression involving an irrational number is called a surd. Okay, so we will be doing examples of surd, and we will be simplifying the expression which involves surd in exercise 4.3. This was the definition of surd. So whenever you get an irrational number in an expression, that expression will be called a surd. Let us start the exercise. Now the first question that you want to practice is question number 1, part 3, and it is that you have to find 3 by 4 into 3 into the not 3 into 3 into cube root of 128. This is what you have to simplify. So first of all, what we are going to do is we are going to find the prime factorization of 128. Okay, the prime factorization of 128 is, first of all, or we can also do it in the exponential form. Okay, first write this in exponential form. Okay, because we are more familiar with exponential forms, therefore it will be more easy for you to attempt this question by first changing this expression to exponential form. After this, do the prime factorization of 128. Okay, and it is going to be equal to, now if you do the prime factorization of 128, then this is equal to 2 raised to power 7. We know that this number is not divisible by 3, so we will try to split this expression in such form that we get powers which are divisible by 3. Okay, for example, 2 raised to power 7 can be written as 2 raised to power 6 into 2 raised to power 1. Okay, because when these two add, it gives us the 7. When bases are same, the powers are added. So I have used this law that a raised to power n into a raised to power n is equal to a plus a raised to power n plus 1. I have split this expression into this. Okay, we have used this relation, this equation in this form, this law. Okay, so we get 1 by 3, and after this I am going to, now we know that whenever you have the product of two numbers and you have a power over it, then it is equal to a into b is equal to a raised to power m into b raised to power n. The power is applied on each and every element of the product. So it will be applied on 2 raised to power 6 also, and it will also be applied on 2. Now as you may see, this will be, the powers will be multiplied, and we are going to get 3 ones are and 3 twos are, 2 raised to power 2. Over here, this will remain under the radical sign because we don't have any power of 2 which is divisible by 3, so it will remain as it is. Now converting this into radical sign, we will have an unresolved radical expression, unresolved cube root of 2. So this will give us an irrational number. Okay, so and 2 square will be cancelled out with 4, and the result will be 3 into cube root of 2. This is the simplified form of this expression, and it involves a surd because of this 2, because of this unresolved cube root of 2. Okay, we could resolve the cube root only up to this number, but the 2 remained under the radical sign. Whenever we have something remaining under the radical sign, that number usually gives us an irrational number. So this is part 1, question number 1, part 3. Let's move to the next part. Now in this question we have to simplify this surd, and the method will be the same. First of all, what you do is you convert this expression into exponential form. After doing that, you are going to do the prime factorization of 96, which will be 2 raised to power 5 into 3. After doing the prime factorization like this, okay, you get this result. And then what you are going to do with these x, y and z, you are going to split the powers. You are going to split this expression and write it as a product of two powers of x, such that the powers are, one of the power is at least divisible by 5. Okay, so x raised to power 6 can be written as x raised to power 5 into x. Okay, find the nearest number to this exponent which is divisible by 5. Similarly, y raised to power 7 can be written, the nearest number which is divisible by 5. The nearest number to 7 which is divisible by 5 is 5 itself. So you are going to write y raised to power 5 into y raised to power 2, because 5 plus 2 is 7. You are going to split this power in the form of two numbers, so that one of the exponent is divisible by 5 and the other may not be. and z raised to power 8 can be written as z raised to power 5 into z cube. After doing that, you are going to open this bracket. This power will be applied to each and every element over here. So it will be applied to 2 raised to power 5. Okay, this number is divisible by 5, and to 3 raised to power 1 by 5. When it's applied to x raised to power 5, it will be 1 by 5, and when it is applied to x, we will get x raised to power 1 by 5. Over here, it will be applied to y, and then z raised to power 1 by 5, and after that z cube raised to power 1 by 5. So over here, this power 5 and 5 will be cancelled out. Same is the case over here and here and here. Okay, and what we are going to get is, we are going to get 2 into 3 raised to power 155 into x raised to power 1 by 5 into y into z, and where is this, we missed something over here, y square. Okay, I am writing this y square at the end because I had missed it. So z raised to power 5, z raised to power 3 by 5, and y raised to power 2 by 5. Okay, so now these numbers are without exponents. So I am going to write the numbers which are without exponent to x, y, z, and over here we had 3 raised to power 1 by 5, then z raised to power 3 by 5, and y square raised to power 1 by 5. All these three had the same power of 1 by 5. So we can write this as 3 y square z cube raised to power 1 by 5, and in radical form this will give us fifth root of 3 y square z cube. This is the answer, and this radical sign indicates that this is an unresolved fifth root of this expression. So this expression will give us the irrational number, because of which we have called this whole expression as surd. Now we have to simplify this expression also. For that, under root 21 can be written as 3 into 7, again doing the prime factorization of each of the number. Under the radical sign, 9 is 3 square, okay, and 63 is now 63 can be written as 7 into 3 into 3. After splitting these radical signs, because under root AB can be written as under root A into under root B. Okay, because of this result, I am going to use I am going to write under root 3 into 7 as under root 3 into under root 7, and this square root sign will be cancelled and will give us 3 over here we will have under root 7, and again here 3 squares, radical sign will be cancelled out and will give us 3. After this, what do we get? 3 will be cancelled out with 3, 7 with 7, and the answer will be equal to under root 3. That's it. Now the next question is five and 243, x raised to power 5, y raised to power 10, and z raised to power 15. Again, we are going to do the prime factorization. First of all, express this expression in the form of exponents. Okay, so this is the fifth root of this whole number. So fifth root in exponential form, it is written as 1 by 5, because this is the power inside the radical sign is 1, and outside the in the index is 5. So first of all, I am going to do the prime factorization of this expression, which will be 3 raised to power 5. Okay, if you do the prime factorization, 243, you are going to get 5 times 3, and you can write it as 3 raised to power 5. Again, we don't need to split this x, y and z's, because the exponent are already multiples of 5. Okay, these can be divided by 5, so we don't need to break these powers. It will be x raised to power 5, y raised to power 10, z raised to power 15, raised to power 1 by 5. Again applying this because we have product over here, so this exponent will be applied to each and every element inside the bracket. Okay, so this will be 3 raised to power 5 raised to power 1 by 5, x raised to power 5 raised to power 1 by 5, y raised to power 10 raised to power 1 by 5, and z raised to power 15 raised to power 1 by 5. Now, because we are calculating the power of a power, so the powers are going to be multiplied and will be cancelled out. Okay, 5 ones are 5 twos are 5 ones are 5 threes are. So what do we get here? We will get 3x y square and z cube. This will be the answer, and this completes the solution. Now in this question we have to add and subtract surds. How do we add and subtract surds? Just as in algebra, we can add the like terms. For example, x can be added to x only and y can be added to y only. So in surds we also do the same, only we only add the like surd, the surds which are like each other. Okay, the same surd. For example, it will be first of all, the method is the same. You are going to do the prime factorization over here. This will be equal to 45 is 3 times 15, which will be 3 into 3 into 5. Okay, again 20 is 2 times 10, so it is going to be 2 into 2 into 5. Okay, plus 4 under root 5. We can't do the prime factorization of 5 because it is already in its simplest factorized form. Now 3 can be taken out of the radical sign because it's the square root, and the square and square roots cancels out, so 3 will, we can pull 3 out of this radical sign, and 5 will be will remain under the radical sign. Minus, we can pull 1 2 out of this radical sign because we are taking the square roots, and 5 will remain under the radical sign. Now 3 under root 5 minus 6 under root 5 plus 4 under root 5. We have like surds. Now all the surds are the same. Now we can add these surds. Okay, we couldn't add it here because all these numbers were different, but now they are same. Taking under root 5 common, you can also do that, or you can just add the numbers which are written with under root 5 directly. Okay, you can add these numbers, or first just, it's more convenient, just take under root 5 common to the right hand side and then add these numbers. 3 negative 6 will be negative 3, and negative 3 plus 4 will be 1. So the answer will be 1 times 5 under root 5, which is equal to 5, and this completes the question. Now moving to the next question. Now again we are going to first do the prime factorization of all these numbers which are under the radical sign. So this will be 4. 12 can be written as 3 into 4, which is 3 into 2 into 2. Okay, plus 5, 27 can be written as 3 into 3 into 3 after the prime factorization. Minus 3 and 75 can be written as, this will be 25, 75 can be written as 25 into 3, which is 5 into 5 into 3. Okay, plus 300 can be written as 3 times 100, means 3 times 10 into 10, and which can be written as 3 times 2 into 5, 2 into 5 will give us 2 square and 5 square. Okay, after the prime factorization. Now out of these we can pull 2 out of the radical sign because it is in the form of pair. The 3 will remain under the radical sign. Plus 5 over here, 3 can be pulled out, and this 3 will remain under the radical sign. Over here also 1 5 will be taken out of the radical sign, and 3 will remain under the radical sign. Okay, plus over here this square, root and square, they will be cancelled out because 2 into 5 will be it can be taken out of the radical sign, and we will have only under root 3 in the radical sign. 2 4s are 8 under root 3 plus 15 under root 3 minus 15 under root 3, and this will be cancelled out, plus 10 under root 3. Now 8 under root 3 plus 10 under root 3 will give us a total of 18 under root 3. Okay, and this will solve the question. Now let's move to the next question. Now in this question they are asking us for the multiplication of surd, because under root 5 is an irrational number, plus this is also irrational number. Two irrational number add up to give another irrational number. So this is a surd, same is the case over here. So we have two surds which are multiplied. The method is the same as bracket multiplication in algebra. You are going to pick the first number and multiply it with each and every element of the second bracket, and then you are going to pick under root 3 and multiply it with each and every term of the second bracket. So the method will be the same as we do the bracket multiplication algebra. Pick under root 5, multiply it with the second bracket, then pick plus under root 3 and multiply it with under root 5 minus under root 3. This will be under root 5 into under root 5 will be under root 5 whole square minus under root 5 into under root 3 plus under root 3 into under root 5 minus under root 3 whole square. Now we know that square and square root are the reverse procedures of one another, so they will cancel the effect of one another. Similarly over here we have the same numbers because commutative law holds under root 5 is equal to under root 3 into under root 5. Okay, these two numbers commute, so they are going to be the same numbers, will be cancelled out. Having opposite signs, we are going to get 5 over here and 3 over here, and the answer will be 5 minus 3, which is 2. Now moving to the next part, which is in our syllabus, that is part 5. Now in this expression, this radical sign over the variable shows that this must be an irrational number. Okay, this is how we indicate the irrational numbers or the surd in algebra. We have a radical sign over the variable. Okay, so this is a surd, this is also a surd, this won't be a surd. Okay, but these numbers are surd. It means that x, whichever number is x, its square root will give us an irrational number, therefore it will be a surd. Now we have to multiply them just as we did before. We are going to multiply them by doing the bracket multiplication. First I am going to multiply these two. We know that a plus b into a minus b in algebra is equal to a square minus b square. Okay, I am going to use this formula. A plus b into a minus b is equal to a square minus b square over here. So we'll get a plus b into a minus b will be a whole square minus under root y b whole square. This is a square minus b square into x plus y, x square plus y square. So a square minus b square, this 2 will be cancelled out because square and square roots are the reverse procedure of one another. They cancel the effect of one another. X, this will be equal to x minus y. Okay, and then I'm going to write this x plus y into x square plus y square. Now x minus y into x plus y, again by using the same formula, will be x square minus y square into x square plus y square. Again we are going to use the same formula because again we have the difference of two numbers and the sum of two numbers. Okay, in place of a we have x square, in place of b we have y square. So we are going to have a, okay, whole square minus this is b whole square. So the answer will be x raised to power 4 minus y raised to power 4. This is how we find the product of surds, and this completes the exercise.